Hi, welcome to Work Energy Power Assignment 1. This is quite an okay assignment, I think. There's a lot of calculation involved, which really trains up and hones up your skills in applying the formula for this chapter. Okay, so there are a few formula that we need to memorize. Okay, so instead of memorizing them, let's do more practice such that it becomes part of your muscle memory. Okay, so definition questions as usual. I'm not going to talk too much about them. Okay, except for some of the things that I think that is worth emphasizing. All right, or else I'll just let you go and quote them from the notes. So what is meant by energy? Okay, I'm going to leave that to you. SI unit is joule. All right, the symbol is capital J. Okay, SI unit. No, sorry. State what is meant by kinetic energy. This one again can be found inside your notes. Formula, all right. EK is equals to half mv square. Okay, I know sometimes it's common to see things such as KE as well, kinetic energy, as in literally, getting the first letter of each word. Okay, but the proper symbol should be EK. Next, state what is meant by gravitational potential energy. Formula, so EP equals to mgh, or PE mgh. State the principle of conservation of energy. Okay, this question is given only 1 mark in this assignment. Usually in papers, we tend to award 2 marks for it, and there are 3 parts to this conservation that we want our students to emphasize. The first point is you need to tell them that energy cannot be created nor destroyed. All right. The second point, you must tell them that energy can only be converted from one form to another. And lastly, reiterate the point, that total energy must remain constant. Okay, all right, so there are 3 points to this principle, so I need all of you to remember to write all these 3 points in. Part B, and the focus is on GPE, which is gravitational potential energy. An electric motor can lift a weight. All right, so usually I would like to highlight a weight 2000 Newton through a height of 10 meters. Calculate the gain in GPE. Okay, so let's see, GPE gain. All right, so so maybe I'm just going to show you some of the nomenclature that I write. Okay, so usually we are not calculating the exact gravitational potential energy, or the exact how do I say GPE. All right, so what we are actually calculating is usually the gain or the loss in GPE. So we're talking about the gain or the loss in the energy. All right, so instead of writing gain in GPE, I will usually just do this: change in GPE. Okay, I will just put a triangle sign, which means change. All right, so the change can be a gain, it can be a loss. All right, so I'll just generally put a triangle sign. An electric motor can lift a weight. Okay, so how do I do this? So it's mgh, right? So, but what is mg? Did the question give you mass? No, they give you weight. So are you going to divide by 10 to find a mass? So you divide by 10, you find a mass, and then after that you multiply by 10 again, because the formula says you need to multiply by g. So please do not be so silly. All right, 2000 Newton is the weight. Mg is actually equals to the weight. So it's actually equals to weight times height. All right, 2000 multiplied by 10. So the answer is 20,000 joule. Okay. Question 3. The diagram shows a fountain that can be used in a garden. Okay, so the height. Well, okay, so this part is a bit weird because I thought that the height should be vertical, but it's a bit slanted. All right, I'm going to assume that this is a vertical height. Okay. The pump raises the water in a fountain to a height of 1.5 meters, and the mass pumped out every minute is 40 kg. Every minute 60 seconds. Okay, we just want to get this clear. So state one form of energy gained by the water. So at first the water was here, now the water is here. I think it's very simple. The main form of energy gain is gravitational potential energy. Okay? Calculate how much energy is gained by 40 kg of water when it is raised through a vertical height of 1.5 meters. The GPE, the G field strength is 10. Okay, so they want how much energy is gained, right, when it is shot upwards. So again, gain or change in GPE is equals to mgh. mgh, write the formula down first. Okay, I always inculcate that. M, in this case, they are talking about 40 kg of water. G, given by the question, G field strength is 10 and H is 1.5 meters. So we just put everything in. Okay, so let me do a quick one. It will be 600. Okay, so every 1 minute, 600 joules of energy is pumped to the water, to help them gain that GPE. All right, that is assuming there's no energy loss. Question 4. A student of mass 75 kg, climbs stairs with a total height of 8.0 meters. G field strength is 10. So same thing, calculate the weight of the student. W equals to mg 75 times 10, 70, oh, oops, sorry. The what? Oh, yeah, 750 Newton. What am I doing? Okay. Calculate the gain in GPE. So change in GPE, all right, equals to mgh. Okay, so again, actually we can straight away use 750, right? We don't have to go back to 75 times 10 times 8.0. Remember, the question gave you that 2SF accuracy. You return them with the 2SF accuracy. Okay, so answer is 6,000 joule. Of course, in this case, there is no need. 6,000 already shows more than 2, or it can be 2 as well. Okay, part C focuses on KE. A 1,200 kg car moves at a steady speed of 4. Calculate the KE. So, so in this case, I'm calculating the exact KE, right? Half mv square. Throw in the formula. Half m 1,002 v 4. Square it, remember, okay? I would suggest, you press in terms of square, or rather like, just press the calculator properly, okay? Because sometimes I have students that, somehow they punch it into the calculator. You have a half times 1,002 times 4, and then they square. Somehow the square is applied to the entire half times 1,002 times 4. So be very careful with that. Half times 1,002 times 4 square is 16, all right? 9,600 joule. Without making any calculations, deduce what will happen to the KE of the car when the speed of the car is doubled. Okay, so this is actually, although a physics question, is very mathematical. All right, a lot of people will just tell me the energy will be doubled since my speed is doubled. All right, that's not true. Okay, look at the equation again. I'm going to put it here. EK equals to half mv squared. How is the kinetic energy related to the V? It's actually directly proportional to the square of the velocity. Okay, so what does that mean? It means that, imagine, okay, now that when my V is 4, okay, when my V is 4, my EK, my kinetic energy is 9,006, right? All right, let's say they say double it. I want you all to try. EK, half times 1,002 times 8 square now. All right, they double the velocity. But if you actually punch this into the calculator, all right, you actually get 38,400 joule. What is actually happening here? All right, if you actually divide by 9,006, you realize it's actually 4 times. Okay, so when you square, all right, you are actually double it, means now it's 2v. 2v squared becomes 4v squared. All right, so when you double the velocity of an object, the kinetic energy associated to it is actually 4 times. All right, quadruple. So, but all right, we just say what will happen. We just say that the KE, the kinetic energy, will be 4 times. Full stop. Okay. All right, if you're not convinced with this, then you can just throw in any other values of v. All right, I mean use smaller values. You can use a mass of just 10. All right, so for the sake of just calculating. So then you can try when v is 2, what is the value of the ek? When now v is 4, I double the velocity, what is the value of my ek? All right, so you'll be convinced by the math. 6. A car of mass 1002 is traveling at a speed of 30. The brakes are applied to bring the car to rest. Calculate the amount of energy that is transferred in the brakes as the car decelerates to rest, to 0. Okay, so let's find out what was the car, what was the EK, the kinetic energy of the car when it was traveling at 30. All right, so it's half times 1002 times 30 meters per second. Oh, this is I think it's very fast, really very fast. Times 30 times 30, I get 540,000 joules of energy. Okay, so the brakes are applied to bring the car to rest. So initially, my car possessed 540,000 joules of energy, all right, kinetic energy. And then when I apply the brakes, the car suddenly comes to a stop. So any more kinetic energy? No more kinetic energy, right? So according to the principle of conservation of energy, my energy cannot be created nor destroyed. So eventually, where did this 540,000 joules of energy go to? All right. Calculate the amount of energy that is transferred in the brakes. In this case, it has been transferred, all right, to the brakes in the form of what energy? All right. So this is actually the amount of energy that is transferred to the brakes. So part B, they ask you, so what happens to them then? What happens to the energy? What did this 540,000 joules of energy become? Brakes is got to do with friction, right? Okay, so what happens? Okay, energy is converted. Main form is definitely to heat. Or, okay, let's not use the word heat. Let's use thermal energy. The thermal energy and sound energy. All right. You can imagine the screeching sound, right? Okay. So, but the main form is definitely thermal. All right. D, conservation of energy, part D. Okay, so we are going to talk about how energy is usually converted between kinetic energy and gravitational potential energy. So a ball bearing is of 2 kg. So let's highlight 2 kg is placed at a point X on a smooth track as shown. Okay, the ball moves from rest down the track and passes a point Y, which is 10 meters below point X. Okay, final point, initial point. Using the the principle of conservation of energy, calculate the speed of the ball bearing at point Y. Okay, so the thing is at X, what does the ball bearing possess? GPE, maximum, right? Any KE? 0. As it falls all the way down, over here, my GPE is now minimum. What's my KE? KE is now maximum. Or, okay. I put 0 here. Okay. So the thing is this. Remember what I told you just now about GPE? Okay, whenever we're calculating GPE, we are not calculating the exact value of the GPE. We're always calculating the difference. Okay, so when the ball bearing rolls down from point X all the way to point Y, the ball bearing lost a height of 10 meters. So by losing this height of 10 meters, the ball bearing loses a certain amount of GPE. Okay, so where did this GPE go to? This GPE is now being converted to KE, because according to the principle of conservation of energy, I can't just destroy my GPE, right? The GPE must have gone to somewhere. Of course, as it rolls down, there is a likelihood that heat and sound is produced. But because the question says that this is a smooth track, means there is no friction, we're going to assume there is no thermal energy loss. Okay. So, what is the change in GPE? So let's write it down first. Change in GPE. Okay, but I'm not going to calculate it first. Okay, the loss in GPE will definitely become the gain in KE, right? We talked about the principle of conservation of energy. So, gain in KE. So I want you to show this step first. Loss in GPE equals to gain in KE. Never put GPE equals to KE, because that is not true. The GPE, the exact value of GPE will most likely not equal to the absolute value of KE. It may be equal, but will most likely not be equal. Okay, so we cannot write they are equal. We need to say the change. So of course you can also spell out the whole entire thing. Loss in GPE equals to gain in KE da 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 da. All right, but you know, I putting the triangle will be more than enough. Okay, so what is the loss in GPE? The formula will be MGH, right? Loss in MGH equals to the gain in half MV squared. Okay, so maybe I will take this away. All right. Now look at this formula. Okay, I mean, if you are already, you know, by Sec 3, I'm expecting you all should be to be quite well versed in algebra. But let's say if you're not, okay, look at this formula. All right, the first thing that I love whenever I'm dealing with algebra is I see common terms on both sides. Right, m and m, I can cancel them away. Right, so GH is equals to half V squared. Okay, so I'm still going to play around with the algebra, and I want all of you to be good at algebra. Okay, it's going to help you with your physics, definitely going to help you with your math. So what do they want? They want speed. Okay, let's, you know, manipulate it step by step. I'm going to move my half over. All right, so by moving half, basically it's 2GH, right, equals to V squared. All right, so but the question wants to find V, not V squared. So how do I find V? I'm going to make V the subject now. But to find V, I need to square root the entire term, right? Square root 2GH. Okay, so equal. How do I find it? Square root 2 times 10 times what's H? 10. So it's square root of 200. All right, I think it's 14. All right. Square root 200. 14.142 meter per second. Round it off to 14.1 meter per second. Okay. So that's it. Okay, we're going to use this very, very often. So you need to I mean, if this is the first time you see this, it is okay that, you know, you don't find it familiar and you find it a bit uncomfortable digesting it. Don't worry, take some time to understand, all right, internalize, and then we're going to see this very often. Okay, so hopefully by the second, the third, or the fourth time, you know, you get used to it and you can actually execute this on your own. Question 8. A lift of mass 400 kg is descending and the speed time graph for the first 25 seconds is shown below. Oh, you see, speed time graph. What topic? Kinematics. So there are a lot of things that we can find, right? The gradient for speed time graph tells us the acceleration. The area on the speed time graph tells us the what? The distance traveled. So, see A, you see? Calculate the distance traveled in the first 25 seconds. So, first 25 seconds, we're talking about distance traveled equals to what? Area under the graph. Write this down, okay? 1 mark. So already we can establish your understanding. All right, so next up is just using the formula to find what shape is this? This is a trapezium, right? So what is the area? Equals to half formula, sum of parallel side. This is 1 parallel side, 2 parallel sides. Okay, so this is 5 and this is 25. 5 plus 25. Multiplied by the distance between the 2 parallel sides. All right, so this is 5. So let's do it. Half times 30 times 5. 75 meters. So the lift actually descended 75 meters. Okay, that's actually quite high. Calculate the change in GPE for the first 25 seconds. So change in GPE equals to mgh. What's the m? 400 kg. G given 10. H, we already know, calculated in the previous part, is 75. So it's 4,000 multiplied by 75. 300,000 joule. Okay, very nice number. Question 9, asterisk. So I'm going to assume it's a little more challenging. So the diagram shows a man making a bungee jump. The man starts his jump from a platform above a river. Okay, so this is the platform. The elastic rope tied to his feet becomes tight when the man reaches point A. So as it drops, so over here it's all loose, right? Loose. From here is tight. Okay, So when it's loose, basically, the elastic rope is not doing its work at all, nothing. So the man is just simply losing GPE and gaining KE, right? Because it's falling. But now I want you to imagine at point A, now the elastic rope is tight now. Not tight, it's now straightened. So all the way from A to B, the man will actually move faster or slower. From A to B, the man will actually start to move slower. So over here, let's call this X, point X. X to A, what is the main energy conversion? GPE to KE, because it moves faster and faster. How about A to B? A to B. A to B, what's happening? Does it move faster now? All right, so you see, he's still losing height. GPE, he's still losing GPE, but he's also losing KE. Right, it's now, how can I lose GPE and lose KE? All right, then what is being gained? All right, then it will be the elastic potential energy in the elastic rope. Agree? Because it gets tighter and tighter and tighter, so it's being stretched. And then eventually when it reaches B, which is the lowest point, what will happen to the bungee jumper? Okay, you will get bounced back up because of the EPE that is inside the elastic rope. All right, it will have the energy to actually pull the man back up. All right, then it changes up to GPE and KE again. Okay. So the man starts blah blah blah. The mass of the man is 80. The G field strength is 10. Describe the energy changes as the man falls from A to B. Okay. So we got it already. Describe the energy changes. Okay. So what will happen? 3 marks. All right. Let's see how we can squeeze out the 3 marks. Man loses GPE and KE. Right. I'm gonna assume this is 2 marks already. Loses GPE and KE, right? Because it's continuing to move down, so GPE definitely must be lost. And as it moves down, does it move faster or slower? It has to move slower and slower, and eventually reaches B, it comes to a stationary point. Okay, because if he's going to move any faster as it goes down, the man is going to land in the river, all right? And then probably this is going to be an accident, okay? Yeah, it will be a death case. So he's going to lose both GPE and KE, and of course, energy is converted to EPE. Okay? I think that's it. 3 marks. Yay, simple. Okay, B. The man falls 56 meters from the platform to point B. Calculate the change in his GPE. Alright, so same thing. Change in GPE. Remember the triangle sign, okay? I'm really inculcating this. Equals to MGH. How heavy is the man? 80. Alright, 80. 80 times 10 times 56 meters. He dropped 56 meters, so very simple and straightforward. 800 times 56. 44,800 joule. Okay? Maximum KE of the man is 23,000 joule. Calculate the maximum speed. Oh, okay. So EK max is equals to half mv squared, right? And they gave you a value already, 23,000. All right. So let's find V. They want you to calculate V. All right. For me, I have the habit of manipulating the algebra rather than punching in the values, because the moment I write in the values, the more values I show, okay, I think it's dangerous because I'm going to commit more mistakes. Okay. So I rather play around with the algebra. So how do I play around the algebra? I'm going to move the half over. I'm going to move the m over. So V square is equals to 2 kinetic energy over m. Right? In between, yes, I skip steps. All right. So if you cannot understand, please pause the video and you try to manipulate yourself step by step. All right. You bring the half over is times 2. Right? You bring the m over is divided by m. Okay. So V is equals to square root 2ek over m. So now I can punch in my calculator value. Punch in the values. 2 times 23,000 over 80, and I square root the entire thing. 2 times 23,000 divided by 80, and then I'm going to square root 575. I'm going to square root 575. All right, answer is 23.979 meters per second. Round it off to 23. 3SF will be 24.0 meters per second. All right. Okay, we're done with this tutorial, this assignment. All right, hopefully you guys have a better understanding of GPE, KE, and the principle of conservation of energy. All right, see you in the next assignment.